In section 5.6, we are dividing polynomials. Our learning objectives are to divide a polynomial by a monomial and use long division to divide a polynomial by another polynomial. When you're dividing a polynomial by a monomial, you want to make sure you divide each term in the numerator by the term that's in the denominator. Since we're dividing by a monomial, there's only one term in the denominator. So to begin this problem, the quantity 10x to the sixth minus 40x to the third, all divided by 5x squared, we are taking 10x to the sixth and dividing that by 5x squared, minus 40x to the third and dividing that by 5x squared. Now you can simplify each of those quotients. So we have 10 divided by 5 is 2. And x to the sixth divided by x to the second, we use the quotient rule for exponents where you subtract the exponents, 6 minus 2. Now the second term, we take negative 40x to the third divided by 5x squared. Negative 40 divided by 5 is negative 8. And then since we have a quotient x to the third divided by x to the second, we subtract the exponents, 3 minus 2. Now we can simplify this to write it as 2x to the fourth minus 8x. So that is your final answer when you take the quantity 10x to the sixth minus 40x to the third divided by 5x squared. In example B, we have the quantity 6x to the seventh minus 10a to the fifth in the numerator, all divided by negative 2a to the seventh in the denominator. We're dividing by a monomial, so we divide each term in the numerator by the term that's in the denominator. So we write this as 6a to the seventh divided by negative 2a to the seventh minus 10a to the seventh divided by negative 2a to the seventh. Sorry, that numerator should be a to the fifth, divided by negative 2a to the seventh. Now we can simplify each of these quotients. We know that 6 divided by negative 2 is negative 3. And using the quotient rule for exponents, we subtract the exponents, a to the seventh over a to the seventh. That's a to the 7 minus 7, which will simplify in the next step. And then we have this minus 10 divided by negative 2. Since 10 divided by 2 is negative 5, it's minus a negative 5. And then the a to the fifth divided by a to the seventh, we're going to subtract those exponents. Let's simplify, and we get negative 3, a to the 7 minus 7 is a to the 0. Minus a negative becomes a positive. 5a to the 5 minus 7 power is a negative 2 power. We can simplify this even further. We know that a to the 0 is 1, so this is negative 3 for the first term, plus this a to the negative 2 exponent, we want to make it positive, so we move that to the denominator, keeping the 5 in the numerator to get 5 over a squared. So the final answer is negative 3 plus 5a squared. In example C, we have a polynomial in the numerator, negative 14x to the seventh plus 6x to the sixth minus 6x to the fifth, all divided by the monomial in the denominator, negative 2x to the fifth. We're going to break this up into 3 division problems, dividing each term in the numerator by the term that's in the denominator. So we have negative 14x to the seventh divided by negative 2x to the fifth plus 6x to the sixth divided by negative 2x to the fifth minus 6x to the fifth divided by negative 2x to the fifth. And we can simplify each one of those. We know negative 14 divided by negative 2 is 7, and x to the seventh divided by x to the fifth. We subtract those exponents. 7 minus 5 is 2. The next term is 6 divided by negative 2, so we write that as a minus 3. X to the sixth divided by x to the fifth. That's going to be x to the first when we subtract those exponents. And then we have this minus 6 divided by a negative 2. So the 6 divided by negative 2 is negative 3, minus a negative 3 is a plus 3. And x to the fifth divided by x to the fifth, that's x to the 0. In other words, that's 1. We can write that as x to the 0. Let's simplify our final answer as 7x squared minus 3x plus 3. For these examples, we want to find each quotient using long division. Here we're dividing a polynomial by a binomial. Since we're dividing by a binomial, we can set this up using long division. We're going to set this up as a long division problem like we used to do in our previous math classes. Since we're dividing by x plus 5, the x plus 5 goes in front, and then the x squared plus 9x plus 20 goes under the division sign. And now when we're dividing, we're looking at the first term in the quantity x squared plus 9x plus 20. We're looking at the first term there, x squared, and the first term of our divisor, x. And I like to write that on the side. What you get when you divide x squared by x, when you simplify it, you get x. So the quantity that we put above the line here is x. And now we're going to multiply this x times the entire quantity, x plus 5. So when we multiply x times x, we get x squared. And then when we multiply x times 5, we get a plus 5x. Now remember, in the long division you used to do in your previous math classes, we're going to subtract that entire quantity. Subtract the entire quantity, and we get x squared minus this x squared is a 0, and then 9x minus the positive 5x. It's a minus a plus 5x. So that's really 9x minus 5x to get a plus 4x. We're subtracting that entire quantity. And now we can bring down the plus 20. Now we're ready for our second step in the division process. We're going to look at the first term of 4x, and we're going to divide that by the first term in our divisor. And when we think about taking 4x and dividing by x, when you simplify that, it goes in 4 times. So we're going to put a plus 4 above the line here. Now we're going to multiply 4 times x and 4 times 5 and put that quantity below. So x times 4 is 4x, and 4 times 5 is 20. And in the long division process, we always subtract that entire quantity. So we have 4x minus 4x is 0, and 20 minus a positive 20 is also 20. So in this case, we have no remainder, and the quotient is x plus 4. So our final answer, when we're dividing x squared plus 9x plus 20, we're dividing that by x plus 5. The quotient is x plus 4. Going on to part B, we're going to set up the long division problem when we're dividing the polynomial 6m to the third plus 26m squared minus 17m plus 15. We're dividing that entire polynomial by m plus 5. Let's set up the long division process. We put m plus 5 in front, and then the quantity 6m to the third plus 26m squared minus 17m plus 15. Now we're going to look at the first term of 6m to the third, and we're going to divide by the first term of our divisor. And I like to do that on the side. So we're looking at 6m to the third divided by m. When we simplify that, we get 6m squared. So the 6m squared goes above in our long division setup. Now we're going to multiply 6m squared times m plus 5. So 6m squared times m is 6m to the third power, and 6m squared times 5, that's plus 30m squared. We're going to subtract this entire quantity. You can subtract the 6m squared and also subtract the 30m squared. Just remember you're subtracting that entire quantity. And when you take 6m to the third, subtract 6m to the third, we get 0. 26m squared minus the 30m squared is going to give us a minus 4m squared. Then I like to bring down the next term of minus 17m. Now we're looking at the first term of negative 4m squared, and the m We're going to set up that division problem. So we have the negative 4m squared. What do we get when we divide that by m? That's going to simplify to just negative 4m. So we can say m goes into negative 4m squared, negative 4m times. So we're going to put the minus 4m. Now we're going to multiply the negative 4m by m and by plus 5. When you do that, negative 4m times m is a negative 4m squared, and negative 4m times this plus 5 is a negative 20m. We're going to subtract this entire quantity, subtract the entire quantity. So negative 4m minus a negative, that minus a negative becomes a positive, and that we get 0, and then the negative 17m minus a negative 20. If you distribute that negative, it's a positive, so this becomes a plus 3m, and then we're going to bring down the plus 15. Now let's look at the first term of our remainder here, 3m, and the first term here, m. And if we take 3m and divide it by m, we can say that 3m goes into m 3 times. So we are going to multiply this plus 3 by the quantity m plus 5. We put the plus 3 above the division setup. So now we're going to multiply 3 times m and 3 times plus 5. So 3 times m is 3m, and 3 times 5 is 15. Remember, we're going to subtract this entire quantity. 3m minus 3m is 0, and 15 minus 15 is also 0. So here we have a remainder of 0, and our final answer is 6m squared minus 4m plus 3. That is the quotient. When we divide the polynomial 6m to the third plus 26m squared minus 17m plus 15 by the binomial m plus 5. Okay, here we're dividing negative 20x to the third plus 17x squared plus 15x plus 13 by the quantity negative 5x minus 2. So that's our long division setup. We are going to be looking at the first term of negative 20x to the third and dividing it by the first term of negative 5x. When you simplify that, negative 20 divided by negative 5 is positive 4, and x to the third divided by x is x squared. So we're going to write that quantity 4x squared, because negative 20x to the third divided by negative 5x, we could say it goes in 4x squared times. So then we're going to multiply 4x squared times the entire negative 5x minus 2. So 4x squared times negative 5x is negative 20x to the third, and 4x squared times minus 2x is negative 8x squared. Now we're going to subtract this entire quantity. Pay special attention to the sign, because when we distribute that negative here, this minus a negative is a plus, and when you distribute the sign to the second term here, minus a negative is also going to be a plus. So we have a negative 20x to the third plus 20x to the third. That's going to give us 0, because minus a negative is a positive. And then 17x squared minus a negative 8x squared is going to give us 25x squared. And we're going to bring down the plus 15x. And now we look at the first term of 25x squared and the first term of what we're dividing by, negative 5x. And we can say that 25 divided by negative 5 is negative 5. X squared divided by x is x. So we're going to write the minus 5x above the line in the division setup. We're going to multiply negative 5x times negative 5x minus 2. So that's negative 5x times negative 5x is a positive 25x squared, and negative 5x times a negative 2 is a plus 10x. And now we're going to subtract this entire quantity. So 25x squared minus 25x squared is 0. 15x minus a positive 10x is plus 5x, and we're going to bring down the 13. Okay, now we look at the first term of positive 5x, and we're going to divide that by the negative 5x, and that goes in negative 1 times. So the minus 1 we put above the line in the division set up. We're going to multiply negative 1 times negative 5x to get a positive 5x, and negative 1 times negative 2 to get a positive 2. We're going to subtract this entire quantity. 5x minus 5x is 0. 13 minus a positive 2 is 11. So in this case, we have a remainder of 11. And we can write our answer as 4x squared minus 5x minus 1 plus the remainder of 11 over what we divided by, negative 5x minus 2. Okay, let's set up the next problem. Here we're taking 4m to the third plus 14m squared minus 5m plus 12, and we're dividing that by m plus 4. So this is the setup. Now we look at the first term of 4m to the third, and we're dividing that by the first term of m plus 4. So 4m to the third divided by m. We could say m goes into 4m squared, 4m cubed, 4m squared times. So we're going to put a 4m squared above the line in the division setup. We're going to multiply 4m squared times m to get 4m to the third, and 4m squared times 4 to give us plus 16m squared. And now we subtract this entire quantity. 4m to the third minus 4m to the third is 0. 14m squared minus 16m squared, that's a negative 2m squared. I'm going to bring down the minus 5m. Now I look at the first term here, the negative 2m squared, and the first term of what we're dividing by, m. And we can say that m goes into negative 2m squared, negative 2m times. So we put a minus 2m above the line in the division setup. We're going to multiply negative 2m times m to get negative 2m squared. Negative 2m times 4 is negative 8m. We're going to subtract this entire quantity. Pay special attention here, because when we distribute that negative, those signs are going to be positive. So negative 2m squared minus a negative 2m squared is negative 2m squared plus 2m squared. So that is going to be 0. And the negative 5m minus a negative 8m is going to be a plus 3m. And we're going to bring down the plus 12. Now we look at the first term of 3m over the first term of what we're dividing by m, and m goes into 3m 3 times. So we're going to put a plus 3 above the line in the division setup. Now we're going to multiply 3 times m to get 3m, and 3 times 4 to get 12. We're going to subtract this entire quantity. 3m minus 3m is 0. 12 minus 12 is also 0. So here we have a remainder of 0. And our final answer is 4m squared minus 2m plus 3. Okay, for these problems, we want to find each quotient using long division. Don't forget to write the polynomials in descending order and fill in any missing terms. So the way we're going to set up this problem with a long division is, since we're taking the quantity x to the fourth plus 81 and dividing it by x minus 3, we're missing a lot of powers of x. So I'm going to put in space fillers of 0x to the third plus 0x to the second plus 0x to the first, and then I'm going to put the plus 81. And we're dividing that by x minus 3. It's important to do those space fillers when you're doing the setup for long division. Now we take the first term of x to the fourth, and we're dividing that by the first term of our divisor, x. And x to the fourth goes into the, x goes into x to the fourth, x to the third times. We're going to put a plus x to the third above the line in the division setup, and multiply x to the third times x to get x to the fourth, and x to the third times minus 3x to get a negative 3x. And now we need to subtract this entire quantity. Think about distributing that negative sign. X to the fourth minus x to the fourth is 0, and 0 minus a negative 3x is to the third. Sorry, that should have been a third there. Is 0 minus a negative is going to be a positive 3x to the third. And then I'm going to bring down the plus 0x squared. Now I look at the first term of 3x to the third, dividing that by the first term of x, and that is going to simplify to 3x squared. We can put the plus 3x squared above the line in the division setup and multiply that by x minus 3 to get 3x to the third minus 9x to the second. And now we subtract this entire quantity. 3x to the third minus 3x to the third is 0, and 0 minus a negative, think about that, distributing that sign to get a positive 9x squared, and then I'm going to bring down the plus 0x. Again, I'm taking the first term of 9x squared divided by the first term of our divisor, and 9x squared divided by x is 9x, and we're going to put the plus 9x above the line in the division setup and multiply by x minus 3. 9x times x is 9x squared, and 9x times minus 3 is a negative 27x. We're going to subtract this entire quantity. 9x squared minus 9x squared is 0, and 0x minus a negative 27x is 27x, and then bring down the plus 81. Now we'll take the first term of 27x and divide by the first term of x, and it goes in 27 times. So we're going to put a plus 27 above the line in the division setup and multiply by x minus 3. 27 times x is 27x, and 27 times the negative 3 is negative 81. And then we're going to subtract this entire quantity. 27x minus 27x is 0, and 81 minus a negative 81 is 162. So this is going to be our remainder, the remainder of 162, and the way that we can write our quotient is x to the third plus 3x squared plus 9x plus 27 plus the remainder of 162 over what we divided by x minus 3. For the next example, we want to put the polynomial in the numerator in descending order. So beginning with the largest exponent, we can say negative 25 x to the third minus 15x squared minus 5x plus 9. We're dividing that polynomial by negative 5x plus 2. Notice the original polynomial, 9 minus 5x minus 25x to the third minus 15x squared. In the numerator, I've rearranged the terms so that the polynomials are in descending order. The exponents are decreasing. Now we look at the first term of negative 25x to the third divided by the first term of negative 5x. We could say negative 25x to the third divided by negative 5x is positive 5x squared. So we're going to put a 5x squared above the line in the division setup and multiply that by the quantity negative 5x plus 2. 5x squared times negative 5x is negative 25x to the third, and 5x squared times plus 2 is a plus 10x squared. We are going to subtract this entire quantity, pay special attention to distributing that negative sign. And we get a negative 25x squared minus a negative 25x cubed, minus a negative, that becomes a 0. And the negative 15x squared minus 10x squared is a negative 25x squared, and then bring down the minus 5x. Now taking the first term of negative 25x squared and the first term of negative 5x, when you simplify negative 25 divided by negative 5 is a positive 5, and x squared divided by x is x. So we're going to multiply the quantity, or 5x times the quantity, negative 5x plus 2. 5x times negative 5x is negative 25x squared, and 5x times 2 is plus 10x. We're going to subtract that entire quantity. 25 minus a negative 25 is 0. Negative 5 minus 10x, negative 5x minus 10x is negative 15x, and then bring down the 9. Taking the first term of negative 15x and the first term of negative 5x, here this goes in 3 times, so we put a plus 3 above the line in the division setup and multiply that by the quantity negative 5x plus 2. 3 times negative 5x is negative 15x, and 3 times 2 is 6. We subtract that entire quantity. Negative 15x minus a negative 15x is 0, and 9 minus 6 is 3. We have a remainder of 3. So we write our final answer as 5x squared plus 5x plus 3 divided by negative 5x plus 2.